here is problem 7. All right, so here again we have a non-homogeneous second order linear differential equation, and the right hand side contains some logarithms, so we cannot do it by undetermined coefficients, so we have to use variation of parameters. The first step is to set up the corresponding homogeneous equation, right? So y double prime plus 2y prime plus y is 0. Then we need to solve it. Okay, so a long story short, the solution is c1 e to the minus x plus c2 times x e to the minus x. Right, so which means that now we are going to look for a solution of the non-homogeneous equation in the form y equals u1 e to the minus x plus u2 x e to the minus x, where u1 and u2 are functions of x rather than constants. Okay, how do we do this? The first step is to find the Wronskian. So the Wronskian is the determinant of the following matrix. The first row is the two solutions of the homogeneous differential equation, e to the minus x and x times e to the minus x. And the second row is the first derivative, so minus e to the minus x. And the first derivative of x times e to the minus x, so we should differentiate it by the product rule. So it's going to be e to the minus x times e to the minus x. Okay, and this is, so first we multiply like this. It's going to be e to the minus 2x minus x times e to the minus 2x minus the multiplication like this. So plus x e to the minus 2x. So these two terms cancel out, and this is just e to the minus 2x. All right, so now we need to find u1. So u1 is minus the integral of what? We insert the right-hand side first, e to the minus x logarithm x times, for u1, we've got to use the second solution of the homogeneous differential equation. So it's going to be x times e to the minus x divided by e to the minus 2x, which is the Wronskian, and these cancel out very conveniently, so let me remove them. Dx, I guess I could do integrated and Wolfram alpha, but now it's just very easy, so it's probably going to be faster if I integrate it myself than open Wolfram alpha. Okay, so we have the minus sign, so we've got to do it by parts. So we take the antiderivative of x squared. It's going to be x squared over 2 times ln x. Minus and minus here is going to be plus. The integral of what? X squared over 2 times the derivative of ln x is 1 over x dx. So minus x squared over 2 ln x. And x squared over 2 divided by x is just x over 2. Its antiderivative is x squared over 4. Okay, so this is u1. Now u2 is the similar integration, but without the minus sign. Okay, so the first term is the same, is the right hand side, is e to the minus x times ln x times, in the second, for the second coefficient, we've got to use the first solution of the homogeneous equation, so which is e to the minus x divided by e to the minus 2x dx, and again e to the minus x cancels out, and the remaining part is just the integral of ln x, and again it's easier to just do it here than to open the Wolfram alpha. So I can write it as 1 times ln x. So I'm going to find the antiderivative of 1, and it's going to be just x times ln x minus the integral of antiderivative of 1, which is x, times the derivative of ln x, which is 1 over x dx. So this is x ln x minus x times 1 over x is just 1. Its antiderivative is x. Okay, so this is u1 and u2. And I guess now I don't need the Wronskian anymore. So I'm going to just combine these two together to get the answer. So my y is going to be u1, which is minus x squared over 2 ln x plus x squared over 4 times e to the minus x plus x ln x minus x times x e to the minus x. Alright, so now let me combine together all the terms with x squared e to the minus x and ln x, and it's this term and this term, right? So I have minus 1 half plus 1 is going to be 1 half x squared ln x times e to the minus x. Alright, and now I'm going to just look at x squared times e to the minus x, and I have these two terms, so I have 1 quarter minus 1, so it's going to be minus 3 quarter x squared times e to the minus x, right? So this is the solution of the non-homogeneous equation, or a particular solution of the non-homogeneous equation. Well, to get the general solution, the complete answer, we should add plus c1 e to the minus x plus c2 times x times e to the minus x, and that's the final answer.